Hello everyone, today we are going to look into the transformations of quadratic relations. And to start with and refresh your memory, I'm going to go over the basic shape of the basic parabolic function, which is y equals x squared. Okay, and here we go again. I already prepared the chart in here, so the table of values is right here, x negative 3 to positive 3, and the y values are right here from positive 9 to positive 9 again, okay? And I'm gonna draw the parabola very quickly with using the step pattern. So we said 0, 0, and then we go move over 1, up 1, over 1, up 3, over 1, up 9, up 5, reaching 9, and then the same thing on the other side. So just a demonstration of how quick it is to draw the graph of a quadratic relation, right? And there goes the parabola in no time. And what is the vertex again? We're going to say the vertex is at 0, 0. The parabola opens up, and when every time we move over 1, we go 1, we go 3, we go 5, and if we were to go even higher, then we would have gone 7 and all the rest of the odd numbers. Now, since all the parabolas have their oversteps the same, which is called the step pattern, then we always refer to these three numbers as the step pattern of the parabola. So this is a step pattern, and the rest of the parabolas will transform based on this main step pattern. Okay, so the next part of the lesson will be an investigation. So what we are going to do this time is we're going to try to add a number to x squared. Remember last time we were placing a number before x squared. Now we're thinking, what if we add a number? What's going to happen? So as always, we're going to use the paper and pencil. And according to the chart, we're going to have in here y equals negative 3 squared plus 2 equals 9 plus 2, 11. Negative 2 squared plus 2 equals 4 plus 2, 6. Negative 1 squared plus 2, that would be 3. 0 squared plus 2 equals 2. And then 1 squared plus 2, that's 3. 2 squared plus 2, that's 6. 3 squared plus 2, that's 11. What I'm going to do is draw the graph. I'm going to let 1 square be 1 unit right here. And we're going to say that when x equals negative 3, y is 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 right here, and negative 3. X equals negative 2, and we have to go all the way to 6. X equals negative 1, y is positive 3. When x equals 0, y is 2. And the other side, we don't have to think hard because it follows the symmetry. And now I'm going to draw the graph of it. Okay, then here we are. Okay, now remember that in the basic parabola, we had 0, 0, right? So it was kind of the same shape. But this time, what we see is that the parabola has shifted. So the shape of it hasn't changed. It hasn't become taller. It hasn't become shorter. But it hasn't changed up and down. So it still opens up. But it has moved, we say. This is what we call a vertical translation. And how many units has the parabola moved? You would say, I see that the vertex, which is actually the best point to refer to, has moved 2 units higher. And we dedicate the move of 2 units higher to the coefficient or to the constant added right here. Okay? So, what are the coordinates of the vertex? We're going to say the vertex is at 0, 2. Direction of opening will be up, And the step pattern hasn't changed really, so we're still going over 1 up, 1 over 1 up, 3 over 1 up, 5. So we're going to say 1, 3, 5 still. In the next investigation, instead of adding a number, we are subtracting a number. And if we were to complete the table of values again, then we would have negative 3 squared minus 3, that's 9 minus 3 is 6, negative 2 squared minus 3, negative 1 squared minus 3, 0 squared minus 3, 1 squared minus 3, 2 squared minus 3, 3 squared minus 3. So here we go again. We have 4 minus 3, 1. 1 minus 3, negative 2. Negative 3. And then negative 2 again. 4 minus 3, 1. 9 minus 3, 6. So we're going to quickly draw the graph of this parabola. So when x equals negative 3, y is 6. 1, 2, 3, 4, 5, 6 here. When x negative 2, y is 1. At x equals negative 1, y is negative 2. And when x equals 0, y is negative 3. And then the step pattern, the y values kind of repeat, so we're going to follow the pattern here. And here I am drawing the graph again. And we're going to say that this is the graph of the function or relation y equals x squared minus 3. Now, where would the have the basic parabola been? So we're going to say where 1, 3, 5, so 3, 1, 2, 3, 4, 5. See, it's kind of fast now, right? So it comes with practice as well. So the more we practice, the faster our brain works actually. Is very similar to training yourself. So if you exercise and you run every day, then it becomes no work, like when you take over a marathon, say, for example. So here we go. We're gonna move on to finding the vertex. The vertex is at x equals 0, y equals negative 3. It opens up still. The step pattern is still 1, 3, 5. It hasn't changed. So the parabola this time has moved, and we call this a vertical translation down. And the reason why it's translated is because negative 3 right here, and the reason why it has moved down is because the negative 3 is a negative, so it has moved in the negative direction. So here is a short summary. What is the effect when a number is added or subtracted to the equation of the parabola? Then we're going to say if we have y equals x squared, and I'm going to call this number k, we're going to say that if that number k here is positive, then the parabola will move up. And if that k is negative, then the parabola will go down. All right?